Okay, here's part 2 on denials. This video will cover conditionals and biconditionals. The last video dealt with denials of conjunctions and disjunctions. Recall that one proposition is sufficient for another just in case the truth of the first means the truth of the second. The only way for this to be false is if the first is true and the second is false. So from the denial of a conditional expressing sufficiency, we have a conjunction where the antecedent is asserted and the consequent is denied. Okay, here's the form. First, we state that it is false that P is sufficient for Q. Or in other words, it's false that if P, then Q. From this, we have a conjunction where the antecedent is true and the consequent is false. For an example of this, consider the conditional, if a creature is a mammal, then it gives birth to live young. This is false. So first we state that it is false that being a mammal implies that the creature gives birth to live young. Next, we show the conjunction. Platypuses are mammals and they lay eggs. The conditional for necessity works the same way. Recall that with necessity, the error of the first means the second is also false. So if it is false that one proposition is necessary for another, then the first is false and the second is true. The form for this is simple enough. First we state that it is false that P is necessary for Q, or that it is false that if not P, then not Q. Next we state that P is false and Q is true. For an example of denying necessity, consider morality and breaking the law. One might think that if you break the law, then you have done something immoral. After all, murder, cheating, and stealing are all illegal and are immoral. However, there are laws that are unjust. Martin Luther King Jr. broke the law in performing civil disobedience, but his actions were moral since those actions were for the defense of civil rights. Next, we have the denial of a biconditional. There's a lot here, but it is actually simpler than it looks. For the denial of a biconditional, we are stating that it is false that the propositions are necessary and sufficient for each other. What this amounts to is that one of the component conditionals is false. Either one of the propositions is not sufficient for the other, or one of the propositions is not necessary for the other. As mentioned, there's a lot here, but it's simpler than it looks. We start with the denial of the biconditional. Next, we state that either P is not sufficient for Q, or that Q is not sufficient for P. Alternately, we state that either P is not necessary for Q, or that Q is not necessary for P. By now this looks complicated, but remember, these last two propositions are actually equivalent to each other. Recall what we learned about denying sufficiency earlier. To show that one proposition is not sufficient for another, we show an instance where the first is true and the second is false. From the denial of sufficiency for the biconditional, we have either that P and not Q, or Q and not P. Alternately, for the denial of necessity, we have either not P and Q, or not Q and P. Take a close look. These are identical except that some of the propositions are in different positions. Thus, these two propositions are equivalent. All this amounts to is that to show a biconditional is false, you merely need to provide an instance where the component propositions, namely P and Q, have opposing truth values. Perhaps paradoxically, the denial for contradiction is much easier to understand. Recall that contradictory propositions have opposing truth values, that is, they are contrary and subcontrary. In order to show that a biconditional for contradiction is false, you merely need to show an instance where both P and Q have the same truth value, either both true or both false. The form is simple enough. We start with the denial of the biconditional for contradiction. This means that either P is not contrary to Q, or P is not subcontrary to Q. Recall our lesson for denying disjunctions from the last video. If we deny that either they are contrary or that they are subcontrary, then we have a disjunction such that either both are true or both are false. We could also look at this by breaking it down into conditionals, but we get the same result with less mess. For an example of this, consider intuition and justification. Some might claim that something that is justified merely by intuition cannot be justified at all. Well, Spock has good news for you. Logic, the very science of justification, is justified by intuition. Without logic, nothing is justified. Here are the terms for this video. You should be able to construct these denials off the top of your head in order to master logic, philosophy, and reason in general. They are handy when you're trying to show that someone's argument is flawed. To do so, you do not merely construct an argument with a contrary conclusion. You must show where one of the premises or where a piece of their evidence is mistaken. To do that, you need to be able to construct a denial. That wraps it up for this series on propositional logic. Master these definitions and techniques. Learn how the propositions are formed according to the definitions of the truth relations, and why the rules of reason work the way they do according to those relations. You will be able to swim through arguments like a shark in open water. There's a lot more to learn. There's a lot more to learn. We haven't even looked at categorical syllogisms, mathematical logic, predicate logic, modal logic, much less inductive reasoning. This short series is only the beginning of wonder and reason. It's the start to freeing your mind.